Hello everyone. Today I'll talk about Fischer projection, and then Fischer projection. From the Fischer projection, I'll convert this one into the R&S configuration. We can figure out from the Fischer projection this my particular molecule is what kind of configuration is R configuration or S configuration. First, let's talk about the Fischer projection. How we can find out the Fischer projection? If you want to find out any Fischer projection from the any particular molecule, what you have to do first, you have to find out the chirality center. So for example, if you be given 2 bromo 3 chloro 4 ethyl octane, then you want to find out what chirality center. Octane means how many carbon? Octane means 1 2 3 4 5 6 7 8 carbon, and you can say this is your number 1, or you can say this is your number 1. If this one is your number 1, number 2nd position you have a bromo, then number 3rd position you have a chloro, number 4th position you have a ethyl, CH2, CH3 is ethyl, then you fill up your hydrogen, CH2, 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 CH3. Okay, this is your what? Make this one is little bit complicated. 4 ethyl octanol. No, 4 ethyl octanol is going to be this is not going to be okay. Yes, 4 ethyl 4 octanol. 4 ethyl. You can say 4 ethyl like a. Okay, let's talk about octane. Octane. Okay. So for example, if you have a given what? 2 bromo 2 chloro 3 1 2 3 chloro 4 ethyl octane. This is your what? This is your molecule. Then what you have to do? You have to do this one is you have to convert it to the Fischer projection. How you can do the Fischer projection? There is a formula for Fischer projection. I'll write for you in the right side. First chirality center. The second is alkyl group on the vertical line. Substitute on the axial line. This is your what? This is your general formula to make a Fischer projection. Without alkyl group on the vertical line, you can make also Fischer projection, but if you do this way, it would be little bit easier for you make a Fischer projection. So how many chirality center is there? There is a, first talk about this carbon. This carbon has a no chirality center. Why? Because 3 bond is the same kind of bond, hydrogen bond. So that's why there is a no chirality center. Let's talk about this carbon. This carbon is a chirality center. How? Look, this carbon is filled up with this carbon, then bromine, then hydrogen, and all the other things. All the other things is one hand. So that's why this one is a chirality center. 4 different bond make a what? 4 different bond make a chirality center. Let's talk about right now this carbon has a chirality center. How? Chlorine is one hand, then this side is a one bond or hand, you can say hand. This is a one, this all entire things is a one bond. So that's why there is a also chirality center. Same thing for this one is a chirality center. This one is no chirality center. Why? This carbon is a 2 hydrogen is in the same kind of bond. That's why no chirality center. This carbon is a 2 hydrogen in the same kind of bond. That's why no chirality center. If you think about this carbon, that carbon, no chirality center. Only 3 chirality center in here. Chirality center is what? 4 different bond. Okay. So if there is a, how many bond? 4 different bond. So how many chirality center find out from your particular molecule? You find out 1 2 3 4 5 6 7 8. Okay. 1 2 3. 3 chirality center. How many chirality center? 3 chirality center. There is a formula for chirality center. What? If you want to find out the sterioisomer. Sterioisomer, if you want to find out what is the formula for sterioisomer, that 2 to the power n. N means number of 2 to the power n means what? N means number of n means number of what? Number of chirality center. So how many chirality center in there? There is 3 chirality center. So 2 to the power n. 2 to the power n is equal what? 8. 8 possible stereoisomer you can make it. So right now I will make a first Fischer projection, then I will make a sterioisomer, so on. Okay. So look right now, think about why I draw the three horizontal line, because there is a 3 chirality center. Then write the vertical line. Okay. Let's talk about carbon number. This is carbon number 2, this is 1, this is 2, this is 3, this is 4, this is 5, 6, 7 and 8. Let's talk about number second carbon. This is my second carbon, and this carbon has a how many bond to fill up? 4 bond. So this CH3 is a 1 bond, but this CH3 is a alkyl, so that's why it's going to be CH3 on the vertical line. And this one is it what? This is a bromine. Bromine is in here. Put anywhere how you want. At the beginning, if you put your substitute anywhere, it doesn't matter. You can put in this side bromine or other side bromine. It doesn't matter. Then another one is H. And the whole entire things is going to be in there, in the bottom position. Let's talk about carbon number 3. Carbon number 3, what happened? This is my carbon. This carbon is filled up with 1 hydrogen and 1 chlorine. Right? And whole the other things is one hand, and in the bottom position is in the one hand. So this 4 hand is filled up. Let's talk about number 4. Number 4, one is CH2, CH3 and 1 hydrogen, and the whole entire thing is alkyl group. It's going to be on the what side? Vertical line. This is your Fischer projection, but you don't know your configuration. Right now your goal is find out the configuration. Okay, so follow my technique. You will never never make a mistake your entire life if you follow my technique. So my technique is what? This is my carbon number 2. My carbon number 2 I'm talking about right now. This is my chirality center. Okay, this chirality center carbon, how my chirality center carbon is filled up? My chirality center carbon is filled up with carbon, with hydrogen, with bromine and with carbon. Yes or not? This carbon, my chirality center carbon directly connect with 4 things: bromine, carbon, carbon and hydrogen. Yes or not? This carbon, hydrogen and bromine. My chirality center carbon is filled up with 4 different things, and we find out our 4 different things. Okay, right now tell me, between these 4, which atomic number is high? Bromine atomic number is high. So right, this is my number 1. Right now you do know carbon and hydrogen, whose atomic number is low. This is going to be number 4. Why? Because hydrogen atomic number is low. Right now we don't know which atomic number is high. Do you know? We don't know, because carbon atomic number and this carbon atomic number is the same. So we don't know whose atomic number is high. Right now your goal, right now the technique is that how this carbon is filled up. This carbon is filled up with hydrogen and hydrogen. Right? This carbon is filled up with hydrogen and hydrogen. How this carbon is filled up? This carbon is filled up with 1 hydrogen, 1 is chlorine, 1 is carbon. So right now tell me which is number, which is number 2. This carbon is number 2 or this carbon is number 2? Obviously this carbon is number 2. Why? Because this carbon is filled up with chlorine, carbon and hydrogen, but this carbon is filled up with hydrogen. So if you compare with chlorine with those one, chlorine atomic number is high because of chlorine or because of carbon, making this carbon is atomic number is higher. Not for the carbon, how my carbon is filled up with. Fill upping atom is making the higher atomic number. So that's why this is number 1, this is number 2. You see, this is number 2 and this is 3. Right? So tell me how is going. So look right now how is going. It's going like that. But we don't care about number 4. So it's going like that. That means it's going like that means what? S configuration, anti-clockwise. when this one is going to anti-clockwise. I'm going to write one more thing. R means clockwise, S means anti-clockwise. Anti-clockwise. So look right now, R means clockwise, S means anti-clockwise. Talk how is going S con anti-clockwise. Anti-clockwise means S. But one thing you have to remember, the lowest atomic number. Atomic number is horizontal line. Horizontal line. Change everything. Change everything. Change the configuration. Configuration. If it is R, it would be S. If it is S, it would be R. So if it is R, it would be S. If it is S, it would be R. So if it is look like R, it would be S. If it is look like S, it would be R. Why? Because if the lowest atomic number on the horizontal line. So look right now, it is going to how? Anti-clockwise, but hydrogen atomic number is lower atomic number in this case, and because of lower atomic number, if it is look and horizontal line, it's make change. What change? If it is look like S, it would be R. This is R configuration. So we find out how we can figure out the R and S configuration. Let's go to the next one. Let's talk about the which one? Next one, this carbon number 3. How my carbon number 3? With fill up with one hydrogen, one chlorine, one carbon and carbon. Between these fours, there's force. Which atomic number is high? Chlorine atomic number is high, number 1. You do know hydrogen atomic number is 4. These two carbon, we do not know. But right now our goal is find out how they fill up. This carbon. Right now we are talking about this chirality center, okay? This carbon, how fill up? This carbon is fill up with, look, hydrogen and this carbon and this carbon. Let's talk about this carbon. This carbon is fill up with one hydrogen, one bromine and one carbon. So tell me whose atomic number high? Because of bromine, this atomic number is what? High. So look right now how this carbon is fill up. This carbon is fill up with bromine, and bromine is higher atomic number than anything. So that's why, because this carbon and this carbon is fill up with, is head is the higher atomic number. That's why this is what? This is 1, this is 4, and this is what? This carbon is 2, this carbon is 3. How is going? This going. This is 2, so it's going how? We don't care the 4, so it's going anti-clockwise. You see, anti-clockwise. Anti-clockwise means what? S, but it would be what? R. Okay. Let's talk about this carbon. How this carbon is filled up? This carbon is filled up with with one hydrogen, one carbon, and this carbon and that carbon. Okay. From this, you do know which atomic number is low. Hydrogen is low. That is number 4. But they are same, right? We cannot figure out which atomic number is high. Right now, what we have to do? We have to do how they fill up. Let's talk about this carbon. This carbon is. Let's talk about this carbon. So how this carbon is fill up right now? Okay, we are talking about this one, right? This carbon, this is my chirality center, okay? So let's talk about this carbon. This carbon is fill up with, look, hydrogen and another hydrogen and this carbon, right? Yes. Let's talk about this one. This one is hydrogen, and this carbon. Let's talk about this carbon. This carbon is filled up with chlorine, then this carbon and then hydrogen. You see, this carbon have fill up, this carbon is fill up with chlorine, hydrogen and carbon, chlorine, hydrogen and carbon. Right now from this, who is high? You do know chlorine is highest than anything. You see, if you compared 1, 2, 3, 4, 5, 6, 7, 8, those 8, which atomic number is high? Chlorine. And this chlorine is attached with this carbon, that's why this part, upper part will get number 1. This part will get number 1. This part will get what? This part will get number 1. This part will get number 1. This part will get number 1. Then you see this carbon and this carbon, how they fill up is the same thing. We cannot differentiate whose atomic number is high, whose atomic number is low. So how they cancel out? This one cancel, this one cancel. But right now we can talk about this carbon and this carbon, how they fill up. This is my carbon. This carbon is filled up with 3 hydrogen. You see, 1 hydrogen, 2 hydrogen, 3 hydrogen. This is my this carbon. This carbon is my this carbon. How this carbon is filled up? Hydrogen, hydrogen and carbon. Hydrogen, hydrogen and carbon. So if you compare them, whose atomic number is high? Because this hydrogen and this hydrogen, this cancel out. Carbon is atomic number then higher than anything right now. So that's why this is the reason. That's why this is number 2 and this is 3. Do you understand? Okay, that's why this is number 2. That's why this is number 2. This is number 2 and this is number 3 and this is number 4. So how it is going? Look, we don't care the 4. We don't care the lowest atomic number is 4, so it's going like that. It's going how? This is 2. It's going anti-clockwise, but lowest atomic number in the horizontal line. That's why it would be what? It would be change everything. It's look like S. You see, look like S, but it would be R. This is R. So you guys understand how you cannot jump directly. You have to go step by step. First, you see that we put how my this chirality center carbon. This is my chirality center carbon, and this carbon is filled up with them. Right now we find out the only lowest atomic number. Then these 3 carbon is the same. We cannot figure out. Then we figure out how they are filled up with. So I figure out that this carbon is filled up with chlorine, carbon, hydrogen. This chlorine is higher than anything attachment. That's why this is number 1. Then this carbon and this carbon we find out the same thing. You see, carbon, hydrogen, hydrogen, carbon, hydrogen, hydrogen. So we don't know what we have to do right now. Then we have to see this carbon. This carbon how fill up? This carbon is fill up with hydrogen, 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 3 hydrogen. But this carbon is fill up with hydrogen, hydrogen, but carbon. That's why this is number 2. And it's going to anti-clockwise. And anti-clockwise means what? S configuration, but the lower atomic number is in the horizontal line. Because of that, this may change everything. What is changed? It is look like S, it would be R. So you find out your configuration right now. If you find out your configuration right now, what is the configuration you find out? You find out your 2R, 3R and 4R. You find out 4R. Okay. Right now you do know there is a 8 possible sterioisomer you can make. So what you can do? You do know if you just change little bit. If you this hydrogen goes in here, this chlorine come in here, this one is going in here. What you can make? You can make 2s, 3s, 4s. Right? Then what other things you can make? You can keep your 2r, but other things you can change 3s, 4s. Okay, then what you can make? Then you can make 2s but 3r, 4s. Right? Then what you can make? You can make 2s, 3s, 4r. Right? Then you can make, okay, then you can make 2s, 3s, 4r. Then what you can make? You can make 2 2s3s4r and 2r3. Okay, we'll find out this one. Then you can make 2r 2s. Okay, then you can make 2r 3s 4r. Then you can make 2r 3s. Okay. Then you can make 2s. Then you can make 2s 3r and 4s. 1 2 3 4 5 6. 1 2 3 4 5 6 7. Then one more possible structure you can make. What you can make? You can make 2s 3s 2s 3s 4r. Oh, we make it this one. Then you can make any other things like 2r 3r 4r 2s 3s 4s 2r 3s 4s 2s 3r 4s. Okay, 3s 2r 4r. Yes. 2r 4r. Oh, you make it. S. Okay, 2r 2s 3s 4s 2r 3s 3s. Make it. One more possible structure you can make. So there is 8 possible structure you make this way, and this is your what kind of, this is your it would be your what kind of structure? Sterioisomer. What kind of it would be? It would be sterioisomer. 4s 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 2r 3r 2r 4s 3r. Okay, 3r 2r. Okay, 2r 3r 4s. So there is a 4 possible sterioisomer you can make it. You see, 2r 3r 4s 2r 3r 2r 3r 2r 3r 2r 3r. Yes, this is the 8 possible sterioisomer you can make it. So what is my conclusion part? My conclusion part: if you want to make a sterioisomer, please be careful with the making the first sterioisomer. If you don't make a first sterioisomer is wrong, if make it wrong, whole things is going to be wrong. So if you don't know how to make it the first one is right, whole entire sterioisomer is going to be right based on your first sterioisomer. So this is your overall Fischer projection and R&S configuration and sterioisomer. So 3 things you learned today. One is Fischer projection, one how you can convert into this one in the Fischer projection, and then you learn how you can figure out R and S from the Fischer projection, and you learned also how you can make a sterioisomer. If you really like my video, don't forget to share with your friend, and don't forget to subscribe. If you subscribe, you can see my new upcoming videos. You can see it, and if you really like it, don't forget to share with your friend, because education is fast and people want to get knowledge. And if you really like, that means you are learning something. If you learn something, share with the others, and it's called social responsibility. Thank you for watching my videos. Hopefully see you in the next videos. Thank you.